This lesson is on what is a limit. Our learning goals for today, we're learning the meaning of the limit of a function in a graphical sense, learning about the limit from the left and the limit from the right in a graphical sense, and we're learning whether or not a limit exists from a graph. Also, we're going to learn to draw the graph of a piecewise function and then discuss limits and whether or not they exist at specific values of x. One way of thinking about a limit is determining the limit of a sequence. So we're going to start with that. So determine the limit of each sequence. In A, you can see the sequence 2.1, 2.01, 2.001, etc. If we think of what happens as this sequence approaches the infinite term, it's going to be 2 with an infinite number of zeros and then a 1. So you can see that the limit of this sequence is going to be 2. The next sequence, 1, 1/5, 1/25, 1, 1/25, the denominator is being multiplied by 5. So the denominator keeps getting larger and larger and larger. And we can see as this sequence approaches the infinite term, it's going to be 1 over a huge power of 5, which is going to divide to approach 0. So we would say the limit, we use capital L for limit, is 0 of that sequence. The next one in C, we have 0.3, 0.33, 0.333. You can see when we have an infinite number of 3's, it's going to approach 0.3 repeat, which is a third. So the limit of this sequence would be a third. In D, we have 9.61, 9.0601, 9.006001. So each time we're placing another 0 before the first 6 and another 0 before the 1. And as this sequence tends towards infinity, there's going to be an infinite number of zeros before that first 6, and the limit of this sequence would be 9. The next sequence in E, 1, -1, 1, -1, 1, -1. This one can trip people up. Some people will think it's 1, some people will think it's -1, and some people think it is 0, which is halfway between 1 and -1. But in fact, as this sequence approaches infinity, we can't predict whether we're going to have a 1 or a -1. So in this case, we say the limit does not exist. In F, we have the sequence 3, 3.1, 3.14, 3.142, 3.1416, 3.14159. And for those of you that have memorized the first several digits of pi, you can see that this sequence is tending towards pi, and the limit at infinity would be pi. 3, 6, 9, 12, 15. We're adding 3 each time, so it's getting larger and larger and larger, and as the number of terms approaches infinity, the limit will also approach infinity. You can't actually equal infinity, so we can say the limit approaches infinity, or it grows without bound is another way of saying it. Okay, so I'm going to stop there after this first example, and then we'll pick up with our next one.